what we're going to do here over the next 3 days that I have all of you, Padilla, the next 3 days that I have all of you is I'm going to pick a topic or type of question, and we're going to get really good at it. That's the idea that I want to do, because I want to work on improving our free response scores. That's the main thing that I want to do. So today's topic, it came up twice on your practice test. So I want to talk about and outline what you're supposed to do, is absolute, max, and min. And I think the issue here is that we know how to do these. We know how to do these problems in the abstract, but then applying them to the specific question that you're being given and put in front of you is causing us trouble, I think. So we're going to try and fix that. In general, here are your steps for absolute, max, and min. Set the derivative or rate, depending on how the question is worded. In general, like the derivative of the function that you're looking for the max and min of. Set that equal to 0. This will find the critical points. Yes? Take derivative, set it equal to 0. Next, know that your max should go from positive to negative, and a minimum should go from negative to positive. And you'll see that pattern that sometimes I start with that sentence. Just like in a lot of different problems, I'll start with an explanation, and then I will move on to actually figuring out where it is in that problem. So if I know I want a minimum, I'll say, well, I have a minimum anytime the derivative is 0 and changes from negative to positive. And then I can just look for where that is. Step 3, this is the important part that a lot of people forget to do. So you have your candidates for your maxes or mins, depending on how the derivative turned out, how you solved it, etc. Now, you're going to compare with the endpoints. If you're asked for the absolute max or min, you need to make sure that your endpoints are not where the highest or lowest value are. All right? So that's our general steps. Figure out what the derivative or rate of the function we're looking for the max or min is, and set that equal to 0. Figure out how it changes. Sometimes you need to make a sign chart. Sometimes it's a graph and you need to look at the graph. Sometimes you put it in your calculator and look at the graph. It depends on the question. Sometimes it'll actually just ask you, is there a maximum, minimum, or neither? And you're going to do this analysis in step 2 to figure that out. Okay, and then once you have figured out what those points are in between, then you also want to compare and check with your endpoints. Okay, so this is the type of question we're going to look at today, and we're going to get as good as we can at it. So I'm going to start by doing one together with you. and then I'm going to have you try some. Aha, there's the rest of the question. It started like halfway down for some reason. All right, this is a calculator question, which means the first thing I see is that I have a function. And so since it's a calculator question, the first thing I'm going to do is I'm going to take that thing and put it in the calculator. And while you're doing that, this is a rate in rate out problem. Here's another thing that I'm going to write down right away. Or underline or whatever. Does it give me some kind of initial condition? All right. So G of t, I want you to think about two things here. First of all, is G of t the rate in or the rate out? And then whichever one it is, where's the other thing? If that's the rate in, where's the rate out? If that's the rate out, where's the rate in? So I'll give you a minute to consider. Is G the rate in or the rate out? It's the rate in, and you can tell that because this is the rate that we are arriving. So gravel is coming in, and so if that's the rate that it's coming in, rate in. So this is my rate in. What is my rate out? This is my rate out. Okay. A of t, I'm going to call it A for amount. The amount of gravel that is there, well, first off, you can think of it as our y-intercept. Our starting amount is the 500, so we're going to put the 500 there first thing. Then we need to factor in the amount in. We need to factor in the amount out. Well, the amount in, we are going to add the rate in. But since we're looking for amount, if we have a rate and we're trying to get back to amount, that's the integral. Integral from 0 to t of g. So we are taking an integral of the rate. Then my rate out is a constant of 100. So the constant of 100 is what goes into my integral. If you did not think of it as an integral and just subtracted 100t, that's fine too, if you want to think of it that way. That might be easier for some of you. So that's my function for amount. Now I'm going to follow the steps. We are looking for a maximum. So I'm going to take the derivative of amount. First off, derivative of 500 is 0. Derivative of the integral will wind me up at g. And then derivative of the integral here, or if you thought about it as 100t, derivative of 100t is just 100. Go into the calculator. Oh, I just figured out that I want to know where g of t minus 100 equals 0. So real quick, here's my g of t. So the function I actually want is that g of t, so y1, minus 100. Okay, and then I'm going to turn this function off so that it doesn't show up. I also have a scatter plot that I'm going to turn off. All right, let's see what Zoom 6 does. Oh, tip when we're looking in these intervals. Let's take a look at where the interval was here. During the hours of operation in the workday, the hours of operation is from 0 to 8. So we might want to narrow our window from 0 to 8. So I'm going to go a little bit to the left of 0 and a little bit to the right of 8. Just so that I'm zoomed in on the part of the function that I want. Sometimes that's really important because sometimes we're looking like from 0 to 300 or something like that. Well, where's it 0? Right there. Okay, let's figure out where right there is really quickly. One, 2, 3, 4. It should be close to 5. It might be 5. I don't think it is, but it might be 5. Yeah, not quite 5. 4.923. And not only that, but it changed from positive to negative. That's a good candidate for a maximum. At t equals, or t is approximately 4.923. Okay. So if we're following along with our steps for how to do these, we have set the derivative of rate equal to 0. We've analyzed where it changed from positive to negative. That was our key points. If we had 2 different points, then we would just write down the place where it changed from positive to negative, because that's the one we care about. So we're on to our last step, which is to compare it with the endpoints. And usually you'll see this done with a table. T, A of t. We have our endpoints of 0, our endpoint of 8, And we have our endpoint of 4.923, the critical value that we found. That is our contest here. In this case, it's going to be the point in the middle, but let's figure that out. First off, we know our amount at 0. What's our amount at 0? At 0, the plant has 500 tons of unprocessed gravel. So we start at 500. And then let me jump to 8. At 8, we have 500 plus the integral from 0 to 8 of G minus, if we have a constant rate of 100 tons per hour, you can do this with the integral, but you can also do this by figuring out that it's going to be 100 times 8. So I'm going to do that as 500 plus math 9 for FNINT from 0 to 8 of my function in y1 dx. And then minus 100 times 8 is 800. $525.55. And go ahead and take a minute and do the same thing with the 4.923 and make sure you can get out the correct value. At 0, the position is at 2. V of t. We want to know when V of t changes from what to what? Negative to positive. At, well, where do I change from negative to positive? That's going to be at 3. 3 is where I change from negative to positive. So then I would make my chart. I have 0, I have 6 as my endpoints, and then I have that candidate that I just picked out of 3. Well, at 0, our initial position is at negative 2. At 3, what happens? We start at negative 2 and move how? Or leftwards in this case. How much? 8. From 0 to 3, we move 8, and we know we move 8 to the left because our velocity is negative. Velocity is negative means we're moving to the left. So we start at negative 2 and we move to the left 8. So we're at negative 10. And then I'll leave you to figure out whether the endpoint eclipses it.